Alright, and welcome to nth level inverses, part 2. By the way, I'm having to use a very weird stylus, which makes my writing very weird as well, so please bear with me. But, in example 1, we have g of x is equal to 5 parentheses x minus 3 raised to the 8th power. Now I want y'all to take a look at this. What in the world are we going to do to find the inverse? In fact, let me explicitly say that. We want to find, see guys, this writing is so strange. We want to find f inverse of x. Well, the first thing I would say is, you know what, let's take a look at my order of operations when this gets a little bit messy or complicated. Here, I know the 5 is right beside the parentheses, so I have an example of multiplication. Alright, I have the 8, I know that that is the example of a exponent, and I have this, the parentheses. Now remember, whenever we're using algebra to solve things, we'll always take getting rid of things in the reverse order. Okay, but more on that in a second. Alright, so the first thing we know is that whenever finding, finding g inverse of x, whenever finding g inverse of x, we know that we always start by transforming our function notation into y. Y is equal to 5 times x minus 3 raised to the 8th power. We also should know that to find the inverse of a function, we simply take our x and our y and we flip them. Alright, so we'll say x is equal to something something y, and what would that look like? Well, we'd say x is equal to 5 parentheses y minus 3 raised to the 8th power. At this point, whenever we are getting rid of operations, well, this is where we're going to use PEMDAS in reverse. We're going to get rid of our multiplication. So how do you get rid of the multiplication of 5? Well, the opposite of multiplying by 5 is to divide by 5. Okay? And so we now have this. We now have x over 5 is equal to parentheses y minus 3 raised to the 8th power. Now this was the heart of our last lesson. How in the world do you get rid of our exponent, the 8th power? What is the opposite of the 8th power? And it is the 8th root. I had a lot of students say the 8th square root. No. The word square means 2, so you can't say the 8th square root. No, you simply say the 8th root. Okay, now of course those cancel. And let's take a look at what we have. We now currently have, just kind of writing this to the side, we have the 8th root of x over 5 is equal to y minus 3. Now here, I'm going to pause the video. I'm going to clean this up just a little bit. So you could pause it to finish taking your notes. Okay, now that we've kind of cleaned this up a little bit, how do we get rid of what was inside the parentheses? How do we get rid of that minus 3? Well, the opposite of minus 3 is plus 3. So we'll add 3 to both sides. And remember, I like to do this step right here, where I'll take my y value, I'll move it over here, and remember, we're going to switch it now back to g inverse of x. And now we'll say, okay, well, g inverse of x is equal to the 8th root of x over 5 plus 3. Alright, pretty easy. Okay, let's go ahead and move on to a second example. Okay, here in example 2, we have h of x is equal to 12 times x minus 500 raised to the 75th power minus 6. Now, notice, we're going to find h inverse of x, and we're going to do PEMDAS in reverse at some point. So let's start by identifying what operations we see. I see that the 12 is being multiplied. I see that we have a parentheses. I see that we have an exponent. And wait a second, I even see we have some subtraction. This is our one new addition from the last time. Now, from here, the first thing we know that we'll always do is take our function notation, h of x, and rewrite it as y. I can say, okay, well, you know what? Y is equal to 12 parentheses x minus 500 to the 75th power minus 6. Now from here, I know that I'm going to always, to find any inverse function, take my x and my y and flip them. And now, of course, we can rewrite the entire equation from there. X is equal to 12 parentheses y minus 500 raised to the 75th power minus 6. Now at this point, let's go ahead and start getting rid of our operations. Working from the bottom, I see the first thing we get rid of is the subtraction. And you ask yourself, how do I get rid of subtraction? What is the opposite of minus 6? Of course, that would be plus 6. And I'll add 6 to both sides. Now from here, we can say, okay, well, we have x plus 6 is equal to 12 parentheses y minus 500 raised up to the 75th power. Okay, the very next thing that we want to get rid of as I go up is my multiplication. I know that I will simply divide both sides by 12. Alright, that cancels away, and we now have this. We now have x plus 6 over 12 is equal to, parentheses, y minus 500 raised up to the 75th power. Now from here, how do I get rid of my exponent? How do I get rid of that 75? Well, we know that to get rid of the 75th power, we will take the 75th root. This is our big idea here. And of course, those will cancel. Now I'm going to pause the video, clean it up just a little bit. I would encourage you to pause it as well and finish taking your notes. Okay, and now we simply have to get rid of what was inside the parentheses. So how do you get rid of a minus 500? Well, of course, we will add 500 to both sides. Now remember my little trick. I like to take my y value. I'm going to rewrite it first, but this time I'll write it first as h inverse of x is equal to everything here on the left. The 75th root of x plus 6 over 12 plus 500. Alright guys, I've got one more kind of unique example. I'd really like for you to stick around and listen to this. Alright guys, so here we have f of x is equal to a parentheses x minus h squared plus k. And you might even recognize this as the vertex form of a quadratic, is the vertex form of a quadratic. Now what I want you to do is find the inverse of this, and that is kind of interesting. Okay, so what in the world are we going to do first? Well, we know the first thing we want to do is we want to go ahead and switch f of x into y. So I say, okay, well, y is equal to a parentheses x minus h squared plus k. What's the next thing I would like to do? Well, of course, I want to switch my x and my y. So I could say y is equal to something something x, which in this case will be y is equal to a parentheses x minus h squared plus k. Oh, I'm so sorry. Look, I didn't even flip my x and my y. Okay, there we go. Now from here, what in the world are we going to do to get the y value by itself? Well, remember our rules of algebra. The first thing we always get rid of is addition or subtraction. So how do you get rid of a plus k? Well, we will subtract k. Okay, and so this would say, okay, we have x, oh, my apologies, wrong color here. We have x minus k is equal to a parentheses y minus h squared. Alright, what are we going to do next? Well, the very next thing that we would like to do is we'd like to get rid of our multiplication, so we will divide both sides by a. And this, of course, gives us now, if I could click the right thing, x minus k over a is equal to, let's cancel, y minus h, close parentheses, squared. Now from here, what in the world would I do to get rid of my square? Well, this is where we take our square root. Now I'm going to pause the video and clean it up just a little bit. I'd encourage you to pause it and finish taking your notes. Okay, so you'll see what we did at the very bottom. We took the square root of both sides, and now, oh, my apologies. That should be a y right there. And now we have y minus h. Well, how do you get rid of the minus h that was inside the parentheses? Well, of course, we're going to add h to both sides. Y'all know my little trick. I like to rewrite my y as f inverse of x, and of course from here we can write the rest of it as we see it. We have the square root of x minus k over a plus h. Alright, so there is the inverse function of our quadratic in vertex form And what you'll notice is that this is a square root function, or aka is the inverse of a quadratic. Alright guys, I hope that this was helpful, and I'll catch you guys in our next video.